Today I am going to discuss about a topic engineering mechanics. First we'll see what is engineering mechanics. Engineering mechanics is a physical science deals with the state of rest or motion of body under the action of force. Next we will see why we study engineering mechanics, because this is a science from the groundwork for further study in the design and analysis of structure. Next we will discuss the classification of engineering mechanics. So mechanics are classified into two groups. So first one is statics and other one is dynamics. And dynamics is further classified into two types. One is kinematics and other one is kinetics. So we will discuss one by one. So first we'll discuss what is statics. Statics is a branch of mechanics concerned with bodies at rest and forces in equilibrium. This is called as statics. And next we will discuss what is dynamics. So dynamics is a branch of mechanics concerned with the motion of bodies under the action of forces. And next we will discuss kinematics. Kinematics is the science of pure motion considered without reference to the force producing or changing the motion. And next we will see that kinetics. Kinetics is defined as the branch of investigates and relation between motion of acting upon them opposed to statics. And next we'll see the basics terms which will be used in engineering mechanics. And statics and dynamics we have discussed earlier. And next we can see that rigid body, the dynamic movement between its parts are negligible, that is called as rigid body. And length, it is applied to the linear dimensions of straight line or curved line. Area, the two-dimensional size of shape or surface is called as area. And next volume, it is a three-dimensional size of the space occupied by the substance. And force, the action of one body and another, whether it is a push or pull force. And next mass, the amount of matter in a body is termed as mass. And next weight, the force with which a body is attracted towards the earth is known as weight. And particle, a body of negligible dimension is called as particle. We will see this diagram. So first particle, a body of negligible dimension. So this is a particle we can say. And next one is rigid body, a body with negligible deformation. See this is a body without any deformation. This is called as rigid body. And next we will go for non-rigid body, a body which can deform is called as non-rigid body. That means what? It will deform when you are applying the forces on it. And next we will go for some basics of scalar and vector. Scalar is generally associated with the magnitude alone. So for example we can say mass and density and volume, time and energy. These are called as scalar. And next one is vector. It is associated with both magnitude as well as direction. For example force, displacement are termed as vector quantity. And next we'll see that some other example, basics concept of force. So force is a vector quantity that describes an action of body one another. So example, in dynamic condition, force is an action that tends to cause acceleration of a object. The SI unit of force is Newton. So 1 Newton is equivalent to the kilogram meter per second square. And next we'll see some principles behind the engineering mechanics. These are the following principles are very important while studying the engineering mechanics. The first one is what? Parallelogram law. And next one is principle of transmissibility. And Newton's first law, Newton's second law and Newton's third law. These are these laws which will be used in engineering mechanics. We'll discuss one by one. The first one is parallelogram law. The parallelogram, we can say two vectors v1 and v2 are treated as a free vector. It can be replaced by the equivalent vector v. which is a diagonal of the parallelogram. So this is a parallelogram and V is a diagonal for these two vectors. This is a parallelogram law of forces. And next we can see principle of transmissibility. A force may be applied at any point on its given line of action without altering the resultant effect external to the rigid body on which it acts. See, this is the force, it is acting on a rigid body. The same force it will be transmitted to the other body without any external defects. This is called as principle of transmissibility. And next we will go for Newton's law of motion. Here we are going to discuss first law of motions. This is the first law. An object at rest or object in motion with the same speed and in the same direction unless acted upon by unbalanced force. It means what? There is a body, it may be in rest or it may be in motion. It will be in the same line of action or same direction in the same speed unless a external force will be acted upon it. This is called as Newton's first law. And we will go for Newton's second law. We know that Newton's second law is what? F is equal to ma. It is what? Acceleration of particle is proportional to the vector sum of the forces acting on it and is the direction of the vector sum. That is Newton's second law. And next one is Newton's third law. Newton's third law, the mutual forces of action and reaction between two particles are equal in magnitude and opposite in direction and collinear. That means what? There is every action, there is equal and opposite reaction will be there. So here we can say there is a force is given into the wall and there is a equal and opposite force are created. These are Newton's third law. So these are the basics things we have to study while going for engineering mechanics, because engineering mechanics is a basic subject which will be used in further subjects, which will be very helpful to the higher semester subject. Thank you for watching.